Okay, this example or this section is on finding the sample size required to obtain a certain level of confidence. After all, normally when you go to do a study, the first thing you do is you think about how many people you should sample, right? Let's say you want your p-hats to be within a certain margin of error. For example, news companies, they use they want a 3% margin of error at 95% confidence. So the question is, how many people should you survey? Well, let's calculate how many people you should survey before you get your sample, rather than just seeing what happens. So the margin of error for a one sample z interval for p is this. You should have hats. Hopefully they have it in your notes. Suppose we want to create a 95% confidence interval to estimate the true proportion of people in the Woodlands that are Democrat, and we want the margin of error to be 3%. So that's kind of this scenario I gave you up here. In other words, we want our point estimate that will be within 3% of the true proportion 95% of the time. How many people should we survey? Well, if we kind of look at this formula, we want our margin of error to be less than or equal to 3%. Well, I know what z is. Z is going to be 1.96, right? That's only dependent on the confidence level, so I know that. I want to find my n, so it's okay that I don't know that. The problem is these two things right here. We don't know the sample proportion nor the probability, how many failures in the sample, because we haven't collected the sample yet, of course. Of course I don't know the true value. I don't even know the sample values. So I don't have anything to put in there. That kind of creates a set of two unknowns, and I can't really solve it for n unless I know these. So how do we handle this problem? Well, there's two things we can do. The first thing, we could estimate p-hat using a quick pilot study. Like we could maybe survey 20 or 30 people real quick and see how many of them are Democrats, what percentage of them are Democrats, and put that p-hat back into the formula. Or we could use historical data. We could maybe look at the last election and say, well, in the Woodlands, about 35% of those who voted were Democrats. Plug those values in and solve for n. Alternatively, we could use the value of p-hat that maximizes this product, p-hat, q-hat, and then put in that p-hat and solve it for n. This is kind of a conservative approach, kind of a worst case scenario approach. But we should probably talk about what value of p-hat maximizes that product. So we want to maximize, this is actually a little bit of math in statistics for a change. Woohoo! We want to maximize the p-hat 1 minus p-hat, this relationship. So let's create a function, f of x. We'll let x equal p-hat. That is simply x times 1 minus x. Not the most exciting function to maximize, but you guys should all be able to do it. Calculus, pre-calculus, algebra 1, you should be able to maximize this. If you expand this out, this is simply a parabola that opens down because it's negative x squared plus x, right? If I factor it, take a negative x out, it leaves me with an x minus 1. So it crosses at 0, has y-intercepts of 0 and 1, and it opens down. To be honest, that's really all you should need in order to maximize this. We know parabolas are symmetric. If it's symmetric, and these are two values on it, then the axis of symmetry has got to be right in the middle of them. So that middle happens at 1/2. So a p-hat value of 1/2 is what maximizes this product. Other ways you could do it, you could complete the square and put it in vertex form. You could do the negative b over 2a and get it that way. If you're in calculus, you could find f prime of x and set it equal to 0. Whatever, this isn't a math class, we don't care. We do care, I'm just saying it's not required for this class, so we don't need to worry about it. What you do need to know is that this is the maximum value. Okay? So we could just put in p hat equals 0.5. Some nice things about using method 2, this conservative approach. You don't have to rely on historical data, which may be inaccurate. You don't have to spend time and money on a pilot study. If you do method 1, so this is going to give you the maximum p hat possible, right? If you use this method and you get a sample, like you get a pilot study value of like 20%, and the real value for your sample is 40%, you're going to have problems because you're basing your sample size off of this value, and whenever you put in a 40%, your sample size isn't going to be big enough. Your margin of error is going to be too big. So if you make a mistake here, you could actually not get the margin of error you want. I don't know if that makes sense to you guys or not, but if you play with the numbers, you'll see that it does. If we use method 2, our sample size will always be large enough, and we will always get a margin of error that we want, or even smaller than we want. There is one big drawback to method 2, however, and that is because it's a conservative approach, if you use it, you might get a sample size bigger than you really needed. Like you might think you need 800, but it turned out you really only needed 500, and you wasted a whole lot of time and money because you're being conservative. So whatever, we don't want to worry about that. We just do what the problem tells us to do. Example, this is all just finding the maximum value. We already did that, so we don't need to do that again. In order to maximize the product of p hat, q hat, we will let p hat be equal to 0.5. So you got to know this. You got to remember this. So let's do this example. Find the sample size required to create a 95% confidence interval to estimate the true proportion of people in the Woodlands that are Democrat with a 3% margin of error. I want my margin of error to be 3 percentage points or less. My margin of error is z-crit times square root of p hat q hat over n. That needs to be less than or equal to 3%. 95%, 1.96 square root. We're going to put in 0.5 for these to be conservative. And I want to solve that equation. Yes, you can solve that equation. However, we don't want to screw it up, so I'm going to put it in the calculator. Hold on a sec. So, as I mentioned, I think I said we don't want to screw it up. I was just talking and not thinking. The thing is, I mean, I guess it's true. We really do not want to mess this up. This is not a class in mathematics. I'm not testing to see if you know how to solve this inequality. And if you're doing this on a test, it's kind of a waste of time. You can use your calculator, you can use the solve function, so let's not increase our chances of making a mistake and waste time by trying to solve it by hand. So let's just type it in the calculator, less than or equal to 0.03, comma n, that's how you use the solve function. Hit enter. Our sample size needs to be greater than or equal to 1067.11. Greater than or equal to 1067.11. Because we're talking about people, we can't do fractions, can't round it down because it wouldn't be less, so we need to round it up to 1068. Almost all the polls you hear about for presidential polls and on news stations, they all survey about 1,000 people. Because that gives you about a 3% margin of error with 95% confidence, so 1,000 is a key number. And by the way, I think they need to survey about 10,000 people to get that 1,000 because so many people hang up on them, which is a problem with non-response, right? But whatever, it's the way it is. I do like to play around with this a little bit. Suppose you wanted a 2% margin of error. So let's just change that to 2%. How many people do we need to survey? So just to go one more percentage point more accuracy, it takes 2,402 people to survey, or 2,000, and one person, whatever. So you got to survey a lot of people. If you're only getting a 10% response rate, that's 24,000 phone calls you have to make. You want a 1% margin of error? Almost need to survey 10,000 people. So 3% error, they said, is kind of good enough. And we could go the other way if you were interested. What about a 5% margin of error? That's a pretty big margin of error. If you do that, you'd only have to survey like 385 people. You could also go back to the 3% margin of error and say, well, what if we wanted to be 99% confident? Put in 2.58. So if you want a 3% margin of error, but you want to be 99% confident, now you need to survey 1,850 people. What if you want 99% confidence with a 1% margin of error? Easy. Just go out and survey 16,000 people. And you're going to get yourself a really good... Jesus. My wife just scared me. So I hope you guys watch this video and think that's just flippin' hilarious. All right. Okay, the last two examples. This one is kind of beyond a BAPS problem. I do kind of want to show you how to do it though. I got 9 minutes. Let's just finish this one here real quick. For your end of year stats project, you want to estimate the proportion of students in the upper school that like math. You want your estimate to be within 4% of the true proportion with 96% confidence. All right, so this is just kind of the same thing. Margin of error less than or equal to 4% this time. Now I don't know what the z-crit is for 96%. A lot of times kids will say, what do I got to put in for p? Do I use the 0.5? Did they give you information from a pilot study? No. So use the 0.5. So let's review how to find that crit value. I want 96% confidence. That's 4 percentage points on both tails. That's 2 percentage points on one tail. That is menu, statistics, distributions, inverse normal, 0.02, 2.05. So let's just edit. I'm not going to type it all in again. I'm just going to grab the one from before. I want a 4% margin of error. And I want to put in 2.0. I'm going to go a little more accurate. 0.0538. Give me a little more accuracy. I need to survey 659.1. My n has got to be greater than or equal 695, 659. 659. So I got to survey 660 people or more. 660 is the minimum. All right, I got 2 minutes. Let's do this. This really is BAPS. Feel free to just skip over this. But remember, and this was, so this problem here was talking about your stat project. And this could come up whenever you guys do your stat project. So this is saying you need to survey 660 kids in the upper school. Well, the upper school only has like 415 kids. So obviously you can't survey 600. So that means you just need to take a census. Well, no, you don't have to take a census. We're basically failing the 10% condition by a lot here. Okay? If you fail the 10% condition, then you need to use that finite population correction factor, which is just this. Basically, you just take your standard deviation and you multiply by that extra factor. I think it works pretty neat. I wish that was part of the curriculum. I guess I could just make it part of the curriculum, pretend it's on the AP test, but I don't do that. So let's do the same calculation above, only let's just add this extra factor in. I'm not even going to write down the formula. I'm just going to add the extra multiplied by that extra factor. It is your population size, 415, minus your sample size, which is unknown, all over 414. So this is harder to solve by hand, by the way, because you got n's in 2 different spots. So that'd be pretty tricky by hand, but these calculators are fantastic. Square root, fraction button, 415